Good afternoon, everyone. आफ्टरनून बच्चावाड़ी. गुड आफ्टरनून, गुड आफ्टरनून, गुड आफ्टरनून बच्चावाड़ी. कैसे आप लोग? गुड आफ्टरनून. गुड आफ्टरनून नासिर. गुड आफ्टरनून बच्चावाड़ी. चलो चलो जल्दी जल्दी जल्दी. गुड आफ्टरनून, गुड आफ्टरनून, गुड आफ्टरनून बेटा. चलो चलो भाई. Shall we start? Shall we start then? Let's look at the concept. Last class, addition of vector we have done, subtraction of vector we have done, है ना? Addition of vectors, subtraction of vectors. Okay, one thing I forgot to tell you. Actually, we have already done it. See here, one special case we had done, if you remember, which was case 2 in addition of vector, which was theta equal to 90 degree, and I told you the resultant you get under root, है ना? A square plus B square, because plus 2AB cos 90 is 0, so 2AB term is missing here, right? Okay, so let's understand with the help of this diagram. Let's say there is one vector here, another vector here. The magnitude is A and this is B. The angle between them is 90 degree. The angle between the vector is 90 degree. Where will be resultant? I told you the magnitude of the resultant. The magnitude of the resultant is under root A square plus B square. But what I didn't tell you was the direction. What I didn't tell you was the direction. Where will be direction? Now, to tell me, to find the direction, what we should find? Last class we discussed in detail. To find the direction, what should we find? If you want to know the direction of R vector, what thing we should find? Come on, Vachavadi. Alpha, very good. Alpha. Not magnitude, beta. I'm asking to find direction, what we should find. To find the direction of a vector, we should find the angle. We should find the angle made by the vector with. Okay, guys, welcome back. Tell me audio video clear or not. Then I will proceed. Come on, please confirm. Audio video clear, bacha badi? हाँ sir, okay, so we shall proceed now. Thank you for your patience, bacha badi. See, so I was telling you ki we have not discussed ki what is the direction of this R vector. To find the direction of R vector, we have to measure the angle between R vector and any one of either A vector or B vector. Means you have to find this angle alpha, or you can find this another angle you can find. Let's call it beta. So if you find the angle alpha, if you remember the last class, tan alpha I told you, alpha is the angle with A vector. So I told you take B sine theta. What theta? What is theta? Theta is the angle between the vectors. Don't get confused. Theta is the angle between the vector A and B which we are adding. And alpha is the angle between resultant and the individual vector, A vector, right? So this theta is 90 degree divided by A plus B cos 90. If you remember cos 90 is 0 and sin 90 is 1. So tan alpha we get B by A. Tan alpha we get B by A, which was quite simple here. If you construct a parallelogram, which will be a rectangle in this case, है ना? Which will be rectangle in this case, because this angle is 90 degree. So you will find if this is B, then this will be also B. So very easily you could have said that tan alpha equal to B by A. Tan alpha equal to B by A. Similarly, if you want to find tan beta is A by B. Means if you are finding, understand, if you are finding angle with A vector, angle between resultant and A vector, take opposite by base. है ना? Tan is opposite by base, means B by A. If you are finding tan beta, for beta A is opposite, है ना? Because if this is A, then this is A. For beta is the angle with B vector, so take opposite A by B. ठीक है? So this formula gets converted into such a simple form. ठीक है? Now, what will happen around 80 to 90% case, you will get this case only, theta equal to 90 degree. So what will happen every time, almost every time, 80% to 90% case, you will be applying tan alpha equal to B by A or tan beta equal to A by B. Now, what happens in that case, you forget the main formula. Please understand, main formula is not B by A. B by A is the formula in the special case where theta equal to 90 degree. When it is some general theta, then this is not the formula. This is a formula valid only in case of theta equal to 90 degree. Please be aware of this thing. Okay, let's do a question to understand this. Let's say there are two vectors, one vector having magnitude 10, another vector having magnitude 2, and theta is, find angle between okay. Chalo bhai. I know some power interruptions are there, but that should not decrease our power. Okay? Chalo bhai. So we were discussing this. A equal to 10, B equal to 2, right? Two vectors. One magnitude is 10, another magnitude is 2. Let's say like this. The angle is 53 degree. Let's say this is magnitude 10, this is magnitude 2. Angle between them is 53 degree. Find angle between R vector and B vector. So this is B is smaller one. So this is B and this is A. So find the angle between resultant. Understand the question. Find the angle between resultant. As I told you, resultant will be closer to the vector having high magnitude, if you remember the last class. Okay? So we have to find angle between resultant and B vector. That means we are interested in this alpha. Come on. Okay, so shall we apply, tell me, shall we apply tan alpha, sir, B by A? You told, sir, tan alpha B by A. So this is angle with B. So I will take A by B. I will take A by B. So it will become 10 by 2, 5. So answer is tan inverse 5. Is it correct? Come on, tell me. Is it correct? Some of you have got the answer. Pujita, you have got it. Ponanjali, you have got it. Okay. Chalo, try to find. If it is no sir, then tell me. Tell me the answer then. Very good. Because theta is not 90 degrees. So A by B or B by A you can't do here. Very good. So if this is not the answer, if you know this is not the answer, then you also know which formula to apply and how to get the answer. Come on, fast. "45 degree, very good. Asrit is saying 45, Radha 45, very good. Dikshit 45, very good. Chalo bhai, dekhte hain. So what we do, so obviously this is wrong. So we will set tan alpha equal to B. B is the opposite vector. If you remember, B is the opposite vector. That means if you are finding angle with B, then I will take here 2. Means A, sorry, A. A means 10. So I will apply A sine theta divided by B plus A cos theta in case if you are getting confused. That's why I am writing here. Now, what is the value of A? Since we are finding angle with B, so B will be alone and here well multiplied will be A if you remember the last class. Sine 53, theta is 53. So let me tell you, sine 53 degree value is 4 by 5, cos 53 degree is 3 by 5. So if you put here sine 53, which is 4 by 5, divided by 2, B is 2 plus 10 into 3 by 5. If you do the calculation, you will get 8 divided by 2 plus 6, which is 8 only. 8 by 8 is 1. So tan alpha we are getting 1. Therefore, alpha will be 45. Means this angle is 45 degree. And if they ask you this angle, angle between resultant and A vector, then remaining, understand, total is 53 degree. Bacha badi, total is 53 degree. This is 45 degree. So remaining is 80 degree. Clear? So I hope you understand which formula to apply. Don't do this thing. Why I'm saying? Because 80 to 90% case, we will be doing this thing. 90 degree case. Only 10% to 20% case, we will be discussing theta not equal to 90. That's why it will be a habit of you to do this tan alpha equal to B by 8. Never do this mistake. Is that clear? Okay. Last class I told you one more thing. If it is a parallelogram, then vector emerging from the common tail is resultant. This diagonal is resultant and this is subtraction. Okay? Means one represent A vector plus B vector. Another represent A vector minus B vector. Correct? One diagonal represent A vector plus B vector, another diagonal represent A vector minus B vector. Now, one question. If magnitude of A vector plus B vector is equal to magnitude of A vector minus B vector, then find angle between them. Them means A vector and B vector. Find angle between A vector and B vector. Them means find angle between A vector and B vector. You already know the formula of A plus B and A minus B. Come on. Ninety. Okay. Hemant, Asrit, Radha, Shrikant, Dikshit, Ben Stokes. Okay. Virat Kohli fan. Rami. Okay. Puranjali. 90 degree is correct. 90 degree is correct. See, two method. First, A square plus b square plus 2ab cos theta. This is the magnitude. A vector plus b vector, correct? A vector plus b vector, this is the magnitude. And a vector minus b vector magnitude is a square plus b square minus 2ab cos theta. What gets cancelled? A square plus b square gets cancelled. So what you can do, don't cancel cos theta, and you say, sir, 1 equal to minus 1 aya. Don't say 1 equal to minus 1. What you do, you bring this minus 2ab cos theta this side and write 4ab cos theta. Please understand. This 2ab cos theta, this is minus 2ab cos theta. Bring this minus here, it will become plus. So 2ab plus 2ab. It will become 4ab cos theta equal to 0. You know 4ab can never be 0. It means कि cos theta has to be 0, means theta is 90 degree. This is one of the method to solve this. This is one of the method to solve this. What is the second method? Second method is if magnitude are same, a plus b vector magnitude and a vector minus b vector magnitude is same. So you are trying to say in this parallelogram the diagonals are equal in length. This is what you are trying to say. Diagonals are equal in length. Tell me, in which kind of parallelogram diagonals are equal? Come on, tell me. In which kind of parallelogram diagonals are equal? This much mathematics is required. Come on. If you don't tell me, I will tell you. See, normally there can be 4 types. Normal parallelogram, then we have rhombus, then we have a rectangle, then we have a square. 4 types. A square. Not only a square, a rectangle also. A rectangle also, beta. In case of rectangle, the diagonals are equal in length. In case of rectangle also, the diagonals are equal in length. So if it is a rectangle, so please understand, if this is a vector, this is b vector. If this is a vector, this is b vector, and it is forming a rectangle. So what is the angle between a vector and b vector? What is the angle between a vector and b vector? It's 90 degree. So diagonals are equal in length in case of a square or rectangle. Therefore, theta is 90 degree. No mathematics, means this is also mathematics, but no such calculations are required. Okay, you can tell directly. So please understand, if anywhere you get a question in which both a vector plus b vector and a vector minus b vector is there, try to apply this concept, diagonal concept. Like one more question I can ask you based on the similar concept. If a vector plus b vector, I mean, I'm not saying its magnitude, I'm just putting a bracket, not a mod sign. If this vector is perpendicular to okay. I think the audio video clear. Chalo. This question we were discussing, right? I have given you this question: if a vector plus b vector is perpendicular to a vector minus b vector, then find the relation between magnitude of a vector and b vector. Think about this. A vector plus b vector is perpendicular to a vector minus b vector, then find the relation between magnitude of a vector and b vector. Come on. I know the flow is getting broken, bacha. Every time it is power cut. हाँ भाई, someone hello hello hello, सबको hello बोलेगा, सॉल्व करो भाई. Magnitude, Rami is saying magnitude of A is equal to B. Pananjali is saying A equal to B. Very good. Why? Can you give me the logic, bacha? What is the logic behind this? A is equal to B. Good. Yeah, the logic is key here they are saying this perpendicular to this one. That means diagonals are perpendicular to each other. Perpendicular to each other. Now the question is, in which case they are perpendicular to each other? Which case they are perpendicular to each other? So they are perpendicular to each other in case of square slash rhombus. They are perpendicular to each other in case of square or rhombus. Okay? What is the thing about the square and rhombus, beta? Sides are equal. In a square and rhombus, both case, sides are equal. If sides are equal, that means magnitude of A is equal to magnitude of B. Okay? Magnitude of A is equal to magnitude of B. Okay? चलो कोई बात नहीं. नेक्स्ट. देख भाई, components of a vector. Now see the new topic. After addition, it's time to do components of a vector. Components of a vector. Bacha badi focus here. If let's say this is x-axis, this is y-axis. And we have to find component of a vector. Let's say some vector is like this. And we have to find component of this vector along x-axis and along y-axis. First of all, you have to understand कि if this started from point A and let's say any particle has moved till point B, okay, you can call it, sorry, this is north direction, this is east direction, so it has moved along northeast direction. It has moved along northeast direction. Okay? So if any particle is going from A to B along northeast direction, can we claim the particle has moved towards right, means east. The particle has moved towards right because somewhere it is to the right side of A, है ना? Somewhere the particle is towards right side of A or east side of A, as well as the particle is also at the north side of A. So the particle has moved towards east also and towards north also. It is somewhere more, है ना, at somewhat more east as compared to A and somewhat more north as compared to A. That means this AB vector can be broken down into two components. And AB vector can be broken down into two components. One along x-axis, another along y-axis. So what you have to do, just remember, we have to, if you want, component on x-axis, drop perpendicular from tail and head on the x-axis. Simple. Draw perpendicular from head and tail of the vector on the x-axis or on whatever axis you want to find the component. We are interested in finding the component of AB vector along x-axis. That's why we have dropped the perpendicular from A and B to the x-axis. So this length this length, है ना, it is known as, if you call it a vector, then this is known as x component of a. This is known as x component of a. Similarly, if you want to find y component of this a vector, then drop perpendicular from head and tail on y axis. This length will be known as y component of a vector. Y component of a vector. Or in vector form, you can draw like this, bacha body, you can draw like this. It is towards right, it is towards right, and here you can draw it is towards up. This is right, this is up. Okay, if they are only interested in magnitude, you can say ax and ay. You can say ax and ay. If vector form, then you can say ax I cap and ay j cap. Now, generally the vectors will be drawn from origin, or you can shift any vector. So in general diagram, you will get something like this, beta. Okay, let's say this is a vector, a vector, making some angle theta. The magnitude is obviously small a, and let's say it is making theta with x-axis. It can make theta with y-axis also, but let's say it is making an angle theta with x-axis. Then, as I told you, drop perpendicular from head and tail. So drop perpendicular like this. Tail is here only, and here you drop perpendicular. So in simple terms, you can write like this. Tell me how much will be this length? This is hypotenuse. Please understand. This is hypotenuse. A is hypotenuse. We are interested in this base, and this is known as y component, or you can say this is y component ay, because this length equal, and this is x component. So if you apply cos theta here, please understand. If you apply cos theta in this triangle, cos theta, base is ax, base is ax divided by this one is a. So what is the value of ax we are getting, beta? A cos theta. Similarly, what will be ay? If you apply sin theta, it will be ay by a. Sin theta will be ay by a, perpendicular by hypotenuse. Okay? Now, in short, what I can say? Video coming or not? Video, bacha body, tell me. Audio video clear hai, bacha? Okay. ठीक है, full clear. Okay. So this is a cos theta, this is a sin theta. This one is a cos theta, this one is a sin theta. Now in simple terms, I should tell you. All clear. Very good. Okay, chalo. Simple thing, beta. If you know angle between vector and axis, listen to me very carefully. If you know the angle between vector and the axis, then you can simply tell the component along that axis is a cos theta. But you will say, sir, but here the y-axis I am getting sine. You are saying it will be always cos. Yes, it will be always cos. Why? Because if this is theta, then this angle will be 90 minus theta. So its projection on y-axis, I should write a cos 90 minus theta. On the y-axis, since the vector is making an angle 90 minus theta with the y-axis, so we should write a cos 90 minus theta. And cos 90 minus theta is sine theta. So remember this point. If a vector is making an angle theta with any axis, then its component along that axis is given as a cos theta. Clear, bacha? That means, bacha, we can write a vector as ax I cap. Now understand, what is the meaning of component? The component means the splitting of one vector into multiple parts. Taking component means splitting a vector into multiple parts. It means what? It means, bacha party, please understand, it means if this component is ax, if this component is ax, in vector form, I can write this as ax I cap. Come on, confirm me. Vector form I can write ax I cap, and this one I can write ay j cap. So what we have done, we have splitted this vector into two parts. Means taking component is just opposite of addition. In addition, we add two vector and make it one vector. है ना? In addition, we add two vectors or multiple vectors and make it one vector. In taking component, what we do, we split one vector into multiple parts, 2 or 3 or any number. Okay? So understand. That means if I add this ax I cap and ay j cap, I will get back a vector. This is the only thing I want you to understand. If you add the component, you will get back the original vector. So that's why don't add ax and ay just like that. We are not adding the magnitude. We are adding the vector ax I cap and ay j cap. That's why any vector can be written in the format of I cap, j cap and k cap, which we already know. We discussed in the first lecture. I told you, I will tell you why we are writing in form of I cap, j cap and k cap. I hope this point is clear, bacha. Remember this point. If a vector is making angles alpha, beta and gamma with x-axis, y-axis and z-axis respectively. Now come to 3D. Then what we can write about x component? What we can, just like I told you, if you know the angle, if you know the angle, you can write simply a cos theta. So angle with x-axis is alpha. Alpha is the angle made by vector with x-axis. So x component will be simply a cos alpha. Y component a cos beta. No need to write sine. Z component a cos gamma. Okay? And what is the net magnitude, better? You can write ax I cap, ay j cap, az k cap. So what will be net magnitude? Can I write ax square plus ay square plus az square. Ax square plus ay square plus az square. Now understand the maths part here. If you put the value ax value is a cos alpha, take a common, a square common, it will become cos square alpha. Ay is cos beta, so it will become cos square beta plus cos square gamma. Okay, then a square cancel. What we are getting? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is another important relation where cos alpha, cos beta, cos gamma are known as direction cosines. Cos alpha, cos beta, cos gamma are known as direction cosines. And alpha, beta and gamma are the angle made by the vector with x-axis, y-axis and z-axis respectively. Chalo. Achha, if I write cos square alpha as 1 minus sin square alpha, you know, है ना? Cos square theta is 1 minus sin square theta plus 1 minus sin square beta plus 1 minus sin square gamma is equal to 1. So it will become 3 minus common sine square alpha plus sine square beta plus sine square gamma equal to 1. है ना? 1 plus 1 plus 1 is 3, minus common, all sine square term addition equal to 1. What I want, you take this sine square term, beta plus sine square gamma, and 3 minus 1 will become 2. ठीक है बच्चा बॉडी, यहां तक क्लियर है? ओके, let's say there is a vector 2i cap plus 3j cap plus 6k cap. Find angle made by a vector with x-axis, y-axis, z-axis. Good, good, good. Okay, but that is, Ponanjali, that is direction cosines, bacha. I am asking you angle, but okay, you have got it. First of all, bacha body, find angle made by vector with x-axis. Means they are asking you to find alpha, then they are asking you to find beta, and then they are asking you to find gamma. Okay. So if they ask you to find alpha, beta, or gamma, है ना? So understand, if you know the component and the complete vector magnitude, okay, then what you can write? You can write AX equal to A cos alpha. How much is AX? X component means I cap. X component means I cap. Okay. So it will be 2. What is complete magnitude? So for that we have to find complete magnitude. It's under root 2 square plus 3 square plus 6 square, which is under root 49, which is 7. So complete vector magnitude is 7. So we should write x component, which is 2, net magnitude is 7 cos alpha. So cos alpha is 2 by 7. So if someone asks you what are the direction cosines, so first direction cosine will be 2 by 7. But I'm not asking you direction cosine. है ना? I'm not asking you direction cosine. I'm asking you angle. So the answer will be cos inverse 2 by 7. So couple of students, no, 3 students have told this 2 by 7, 3 by 7, 6 by 7. But these answers, you are almost there. 2 by 7 is not the angle. Cos inverse 2 by 7 is the angle. 2 by 7 is the direction cosine. I hope you understand this point. long term student, Porankit 2, I scored 496. Good, it's a good marks in, you can consider it is equivalent to almost 600. 496 marks, you can consider almost equivalent to 600, more than 600 in 24, because 24 was much easier. Okay, I got it. I got it. You might have got the answer in cos inverse, but Hana, you didn't want to write that. Very good. Chalo, ठीक है. Good. Chalo, similarly, with y axis, a cos beta. Come on, I want all of you to answer here. Come on, bacha badi. Ay is 3, y component is 3, total is 7. Cos beta is 3 by 7, beta is cos inverse 3 by 7, and similarly I can say gamma is cos inverse 6 by 7. ठीक है? Yeah, in track 1, correct. In track 1, the paper was little bit easier side as compared to track 2. That's why you might have got questions from the classwork only. Whatever we have done in the class, similar question they have asked. Because track 1 was little bit on easier side as compared to track 2. You will get this year also, don't worry. चलो समझ में आ गया. So if I ask you find direction cosines, बच्चा बड़ी, what should have been the answers if I ask you find direction cosines? Find direction cosines. Then what should have been the answer? Then answer should have been 2 by 7. The answer should have been 2 by 7, 3 by 7, 6 by 7. Simple. But if they ask angle, then you have to mention in cos inverse. I hope this point is clear. Chalo. Next question. Let's say this angle is 37 degree. This one is 53 degree. This is 15 Newton. This one is 20 Newton. This is 10 root 2 Newton. This angle is 45 degree. Are we back? Okay. ठीक है. Should we solve easy question first? Should I tell you how to find the components? Like in projectile motion, bacha badi. Wait 1 minute. Like in projectile motion, you will get this is 10 meter per second. This angle is 37 degree. Find the x and y component of the velocity. Let's first solve such simple questions. Then only we will move towards those questions. है ना? 10, 37 degree. Find the component, x component of velocity and y component of velocity. Here also, they will say the rain is falling, this and that. We are not going to numerical. We are just asking you to find the components. Let's say this is 20 meter per second and this angle is 60 degree. Find x component and y component. Come on, at least tell me the answer of such question, bacha. I know there is a lot of power interruption. This is the 5th time it is happening. But you will have your video, hai na? At the last you can see in one go. Those who are still here, whose patience level is high, please tell me the answer. X equal to 8, y equal to 6. Okay, correct, Tarini, correct. See, the x component will be simple, 10 cos 37 degree. And where there is no angle, or you know this angle also, 53. So either you can write, please understand, if you find this angle, this will be 53. Either you can write 10 cos 53 degree, or you can prefer to write this side 37, so cos, so remaining side it will be sine. 10 sine 37. 10 sine 37. Okay. So this will become cos 37, as I told you, it will be 4 by 5. So it will become 8, and this will be 10 into 3 by 5. So it will become 6. Can you tell me in I cap and J cap format how we can write in I cap and J cap format? Come on. How can we write this? Let's say this vector is u vector, u vector. So how we can write u vector in I cap and J cap format, beta? Chalo, chalo, chalo. I cap and J cap format. Yes, x component is 8 and y component is j. 8 I cap plus 6 j cap. Very good. Can you do the same thing here? Come on, bacha body. Can you do the same thing here? Write the vector, write that in vector form, I cap and j cap. Consider this as x-axis. Consider this as y-axis, but I will consider downside as negative y-axis. Take care of this thing. This is negative y-axis. So what will be component here in this case? This case, okay, a lot of you have given the correct answer. Very good. Ha bhai, so what will be x component? It will be 20 cos 60 degree. Cos 60 is half. And this will be 20. Either you can write cos 30 or you can write sin 60. Both of the answer will be correct because it will be same only 10 root 3. Now can we write, let's say this is v vector they are saying, can we write v vector in vector form I cap and j cap? Help me here, I cap and j cap. Nasir, that is correct. Almost correct, you missed that j part. Pananjali, that is also correct, bacha. Kirtini, that is wrong, beta. Not plus, because the y component is downward, you should take it negative. Radha is correct. Rami, correct. Very good. So since this is right side, generally right side we take as positive. So I will write it 10 I cap. I will write it 10 I cap. But since it is downward, and generally downward direction by convention we take negative. Upward we take positive. Downward we take negative by convention. So it will be minus 10 root 3 j cap. Okay? Okay. Although I know it's just a basic thing, but please understand, if any vector is along x-axis, any vector is along x-axis, let's say this is v. So what is y component? What is y component of this? Let's say this is 10 meter per second. है ना? So what is x component, what is y component of this vector? If vector is completely along x axis, then what is its x component, what is its y component? Come on, because in projectile motion we will be doing such thing. So if a vector is completely along x axis, so its x component is complete 10 and its y component is 0. If a vector is completely along x axis, then its x component is 10 and y component will be 0. ठीक है? And you can write 10 I cap. Similarly, let's say this is the acceleration g, we say. Okay, what will be the x component of acceleration and y component of acceleration? Yes, x component of acceleration will be 0 because the vector is completely along y axis. Vector is completely along y axis, so its x acceleration will be 0 and y acceleration will be g. Plus g minus g, that will depend on the sign. Don't worry about that. But x component is 0 and y component is z. Remember this point? Because this will be used in projectile motion and at multiple other places. I hope this point is clear. Okay? Now come to this question. You can take minus g also, but since I am interested in only magnitude, the scalar component, that's why I was writing g. Vector form, you can write minus g j cap. No, understand the question. I'm not asking F net, but beta, what I'm asking is ki find minimum force that should be added to get net force along y-axis. Find minimum force which should be added to get the net force along y-axis. First of all, tell me the net force in I cap and j cap format. Tell me the net force in I cap and j cap format. No, that is wrong. Tell me the net force in I cap and j cap format. Is it getting cancelled? Why you are saying 3? Okay, bacha buddy, let's check. I have just given random data, so the answer might be 0 also, but we will check. Let's start with taking component of this 15. This 15 will have one component along x-axis, positive x-axis, and another along positive y-axis. So this component of 15 will be 15 cos 37. Can I write directly? Come on. 4 by 5. Come on, bacha buddy. Keep your attention here. 15 cos 37. Cos 37 is 4 by 5. So it is coming out to be 12. X component 12. What will be answer here? So it will be 15 sine 37, which is 3 by 5. It is 9 Newton this side. Okay? Chalo, the component of 15 we have taken 12 and 9. Component of 10 root 2, one component, since it is in this direction, so its x component will be left. While 15x component was right, the 10 root 2x component will be left because it is pointing in left side. And its y component will be again same direction, up. So 10 root 2 cos 45. Cos 45, everybody knows it is 1 by root 2. So 10 root 2 into 1 by root 2 will be 10. And this will be also 10. Tell me, any doubt? 10 root 2. Its component will be 10 and 10. Thick? Come to this 20 Newton. The 20 Newton will have a component one towards left and another towards down. This left side component will be cos 53. So 20 into cos 53 is 3 by 5, which is 12. And this component will be 20 into 4 by 5, which is coming out to be 16. So that means we have splitted 3 forces into 4. Okay. Now, if you add all the x component first, so we are having 10, 12, 22, and this side also 12. So basically 12, 12 cancel, left side it is 10. So right now the net force is minus 10 I cap. On the y-axis, we have 10 and 9, upward direction 19, and 16 in the downward direction. So we should write plus 3 j cap. Plus 3 j cap. So it's minus 10 I cap plus 3 j cap. Minus 10 I cap plus 3 j cap. This is the net force right now. Okay. But what is the question? Question is ki what minimum force should be added to get net force along y-axis? If you want to get net force along y-axis, that means you want only j cap in the answer. You want only j cap in the answer. You don't want any I cap because you want net force along y-axis. That means you don't want any x component. So for fx to be 0, the extra force which we should apply, that should cancel this minus 10 I cap. So which force will cancel minus 10 I cap? It will be 10 I cap. That means extra force should be applied towards right. And what magnitude? 10. Then this 10 I can cancel, and then the net force will be 3 j cap. I hope this question is clear. It's a tough question. ठीक है बच्चा बाड़ी है ना? After the lecture also please or after the lecture please try to solve it once more because high chance कि will get stuck here. ठीक है? चलो, let's solve some question from maths NCERT which we have solved some 6-7 questions. Come on yaar. Okay, but one more point. चलो भाई, vector joining 2 points. Vector joining 2 points. Bacha badi, if let's say there are 2 points A, B, and you have joined these 2 points, है ना? So there is a vector joining A and B, and from A to B. Please understand this. We call this vector as AB vector. We will call this vector as AB vector from A to B. From A to B. है ना? So let's say the x coordinate here is x1, y1, and z coordinate is z1. This one is x2, y2, z2. You can call this at displacement vector also. If a particle was at position A and now it is at position B. So the displacement will be from A to B, initial to final. Tail is initial, head is final. Tail is initial point and head is final point, and you can say that this is a kind of displacement vector or vector joining 2 points. ठीक है? A to B, not B to A, not B to A to B we are saying. Then this AB vector, if you know the x coordinates, y coordinates and z coordinate, what you can write? You can write final minus initial means x2 minus x1, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Simple. Final minus initial x coordinate I cap, final minus initial y coordinate j cap, final minus initial z coordinate k cap. That's how you write the vector joining any 2 points. And if you are interested in the magnitude, what is this distance between 2 points? What is distance? So you know I, j and k. So what you have to do? You have to do under root x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. Here, if you are finding the magnitude, it doesn't matter which is initial, which is final, because eventually you are squaring it, so it will not matter. But if you are writing in the vector form, then x2 minus x1 or x1 minus x2, it will create a difference. That's why I'm saying it's AB, not BA. If you are writing BA vector, then it will be x1 minus x2. Final minus initial. Always write final minus initial. This is also in mathematics, it is known as distance formula. Okay, what is the distance between 2 points? What is distance between 2 points? ठीक है बच्चा? If it is fine, then in motion in a straight line, there is a term which is known as position vector. What is position vector? Let's say there is a point over here, A, whose coordinate is x, y, z. Whose coordinates are x, y, z. What is the position vector? So first of all, position vector is vector drawn from origin to the given point, whose position vector we are trying to find. From origin to the given point. Please understand. Don't draw opposite. From origin to the given point. Vector drawn from origin to the given point, we call it position vector. This vector will tell you where the object is situated. See, either if you tell the coordinate, then also we know where the object is situated. Like it's 1, 2, 3. So if coordinates are known, means we know the location of the object. But same thing can be written in vector form also. Means coordinates can be changed into vector form. So understand. So position vector is nothing but the line joining origin and A. Line joining origin and A, and according to the previous logic, origin means 0, 0, 0. So it will become x minus 0 I cap. Come on. X minus 0 I cap, which is x I cap, y minus 0 I cap plus. So if you know the coordinates, somewhere you also know the position vector. If you know the coordinate, so somewhere you also know the position vector. That means if the coordinate is 1, 2, 3, then position vector will be simply I cap plus 2j cap, I cap plus 2j cap plus 3k cap. It's so simple. Chalo, solve this. Maths NCERT. Come on. Last 10 minutes. We will solve some questions. Come on, come on, come on, fast. This is important. From P to Q. So that means from P means P is initial and Q is final. So something like this. From P to Q. So this is Q and this is P. So we should do final minus initial, correct? Final minus initial. Okay, so PQ vector should be, है ना? Q minus P, right? So 1 minus 2 I cap plus minus 2 minus 3 j cap plus minus 4 minus 0 k cap. So it is minus 3 I cap minus 5 j cap minus 4 k cap. Yes, it should be Q minus P. Anyone given correct answer? Srisha is given correct answer. Triveni is there. Then Radha, Nasir, Ponanjali, and anyone else? No, Arun. And then no. Okay. But I hope you understood this basic thing. Final minus initial. From P to Q means P is initial, Q is final. So you have to subtract Q and P. है ना? Q minus P. चलो. चलो ये तो इजी हो गया, ये तो काफी इजी है. Because we are, see what is happening, we were doing this example, after example we are going to exercise, so these are supposed to be easy question. Like a quick revision if you want, can you tell me the fast answer of find the magnitude of all the following vectors? Means starting from lecture 1, this is lecture 4 going on in vector, so you can say we are testing the knowledge of lecture 1 to 4. Come on, fast, but you have to be fast. Quick revision. What is the first answer? Okay. हाँ भाई, first answer under root 1 square plus 1 square plus 1 square. It is root 3. It is root 3. Come on, tell me the second answer. Come on, first. Okay, 3 answers we have got. Chalo, 3 people have given complete answer. Come on, tell me the magnitude of B also, beta. Under root what? Come on, fast. Under root 62. Many of you are saying under root 62. Okay, okay, okay. Let's check it. 4 minus 7 doesn't matter, as I told you. It will plus 49 plus 9, 13, 13. Yes, you are correct. And similarly here also, it will be 1 by root 3 square, root 3 square. So it will be 1 by 3, so it will become under root 1, which will be 1 only. Okay? So far so good? Chalo, write two different vectors having same magnitude. Can you write two different vectors having same magnitude? Come on. And write two different vectors having same direction. Come on, come on. Check your basic knowledge. We are checking here basic knowledge. Come on. Write two different vectors having same magnitude. So magnitude should be same. Direction can be different. So having same magnitude, I can write 3i plus 4j, our favorite. And then I can write 3i minus 4j. Correct? See, same magnitude we will get. Right? 4i plus 3j means you can do whatever changes you want. Come on, write two different vectors having same direction. Same direction means they are talking about collinear vector, parallel vector, collinear, parallel. So that means we can write any vector like 3i plus 4j again take, and then what we can do, we can multiply some positive number to it. Like we can multiply 2. So it will become 6i cap plus 8j cap. While the magnitudes are different, but the directions are still same. I hope this point is clear. First one is same magnitude but different direction. Second one is different magnitude but same direction. Clear बच्चा पार्टी बोल दे यार. Find value of x and y so that the vectors are equal. It's so simple. Come on, come on. Tell me the answer fast, fast. Two and three, so simple, because if vectors are equal, then x component will be equal, y component should be also equal. That is the only criteria. Okay? So here x, here 2. So x is 2, y 3, y is 3. Maths NCERT, they ask a simple question only. Yaar. Chalo, chalo. Find the scalar and vector component of the vector with initial point 2, 1 and final point -5, 7. So can you write the vector? Can you write the vector? Initial point, final point is given. It should be final minus initial. Come on. Yes. So this vector we can write final -5. Here it is -5. Here it is 2. So -5 minus 2 I cap plus 7 minus 1 j cap. So S vector will be -7 I cap plus 6 j cap. Okay? But if they are asking a scalar component, so scalar component will be -7 and 6. Scalar component will be -7 and 6. And vector component will be -7 I cap and 6 j cap. So what is the difference between a scalar component and vector component? Only this unit vector. If this ask a scalar component, just take this 6, 7 like this. And if they ask vector component, put I cap and j cap also. Put I cap and j cap also. Yes, the direction is the main difference between a scalar component and vector component, and direction is represented by unit vector. I hope this point is clear. Chalo, these questions are easy. We are skipping it. This one you can write, you can solve. Find the unit vector. Please understand, find the unit vector in the direction of PQ vector. PQ means P to Q. So first of all, you need to write the vector. You need to write the vector. If you say this is S vector, so P and Q, Q minus P. PQ means you have to do Q minus P. 4 minus 1, 3. 5 minus 2, 3. And 6 minus 3 is 3. But this is not the answer, because they are interested. They are interested in unit vector. That means you have to find the magnitude also. The magnitude will be 9 plus 9 plus 9, which is, I think, under root 3 root 3. So unit vector will become, I think, 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. Yeah, root 27 we can write 3 root 3. Then 3 and 3 will get cancelled if you divide it. Now this much first we can do. Hai root 27 I have written 3 root 3. Please understand. Chalo bhai. Last question of today, which will be discussed. All PDF I will discuss in tomorrow class na. Kahan gaya? What you do, you take a screenshot of this question. If possible, take a screenshot of this question. Attempt it, and then we will discuss in the next class. Next class, we will discuss this PDF first, then I will start dot product. 2 lectures are still there. 1 lecture I will go for dot product, another one I will go for cross product. ठीक है बच्चा बाड़ी? If done, think about this distance formula, apply distance formula. Okay, so that will be my time. Is there any chance to get AIQ for 496 general? Okay, it is there, but please go through the video of Narendra sir. You will get a complete picture there. ठीक है बच्चा बाड़ी? Chalo. Okay, बच्चा बाड़ी, that's my time. See you in the next class. We will discuss dot product and cross product, and also we will do these questions. ठीक है? Chalo, tada, bye bye.